All right, we are going to start the next target, which is 0B-5. All right, reviewing integration stuff. So we just got this and one more target 6 to do. So I wanted to review some application stuff like slope fields, Riemann sums, which Riemann sums were pre-area. We'll talk about that in just a second. And then motion problems that involve integrals, not just derivatives. All right, so our outcomes, I can use integration to solve problems. So all these things involve integration application. So if you remember slope fields, slope fields, all right, there were 4 things you should be able to know how to do with slope fields: be able to sketch one, be able to sketch a solution curve, be able to match a differential equation to it, and be able to match a solution curve to it. All right, so those were the 4 things. So if you remember sketching a slope field, this is a differential equation. And so you're given a grid with some dots on it, and you're asked to sketch this slope field on this grid. All right, so to sketch this slope field, you just keep putting in the coordinates in for x and sketch little slopes, little tangent lines, little teeny ones, just little tick marks to represent the slope at that point. And it gives us a slope field or a whole graph of a bunch of slopes. All right, so if x is 0, if x is 0 here on the y-axis, everything would be 1. So we would sketch 1s on here. Hope you remember how to do this. When x is 1, that's going to make a slope of 2, so we just make them steeper. When x is 2, we just make them even more steeper than the last time, all right? Just make them steeper. And then when x is -1, we're going to get a slope of 0, so these would be horizontal. And then when x is -2, we're going to get a slope of -1. All right, so that's a slope field. And remember, if we're in x's, all your columns will be the same. So I hope you remember that. And then we can do what's called a solution curve. A solution curve would be if you pick a point on here and then you follow the river and make a sketch of the solution curve on the grid, right? So that's a solution curve. So hopefully you remember how to do all that. All right, so this one is only in y's. So if it's only in y's, that means your rows are going to all be the same, remember? So when, say when y is 0 on the x-axis here, this is going to be 0, so all these would be 0 along the x-axis. When y is 1, they're all going to have a slope of 2. Let's see, a slope of 2, I go towards the box corner that's 2 things down, and then I make them all look kind of the same. And then when y is 2, that's going to give me a slope of 4, so let's just make it steeper. And then when y is -1, that's going to be a slope of -2. So a slope of -2 would be about like this. And then at -2, we're going to have a slope of -4. So you just make it steeper. All right, so that's what they look like. And my rows are all the same because I'm in y's. All right, and then when you're in x's and y's, that's when your columns, especially if you're x plus y or x minus y, your diagonals will all be the same. All right, so then it's a little more complicated with this many points. It takes a lot longer. So if I did 0, 0, that's an easy one. If I do 0, 1, that's going to be a slope of 1. 1, 0 is going to be a slope of 1. 0, -1 will be a slope of -1. -1, 0 will be a slope of -1. 1, 1 would have a slope of 2. And 0, 2 would have a slope of 2. 0, -2 would have a slope of -2. -1, -1 would have a slope of -2. 0, 2 is going to have a slope of 2. No, that was 1, 2, sorry. 1, 2 is going to have a slope of 3, and then 2, 1 is going to have a slope of 3. And then you just notice your diagonals are the same. 2, 0, all of these are going to have a slope of 2. Those have a slope of 3. This has a slope of 4. These all have slopes of 1 because I'm 2, -1. These are all going to be slopes of 0 because I'm on the negative diagonal. So 1, -1, 2, -2, those added together will give me 0, so all along that diagonal. all along this diagonal, they'll have slopes of 1. These will have slopes of 2 and 3 and slope of -4. Those are all negative. All right, and you'll notice your solution curve will be a little more interesting on this one. Depends on where you start. If I start here, it might do something like this and go up this way. If I start right here, I may just go up like this and come down like this. So it depends on where you start. If you start here, it may come like that and then go around like that. Okay, so depends on where you are, what your curve looks like. So on this side, they might look somewhat parabolic. On this side, they look kind of not really a straight line, some type of curve on that side. So that's your solution curves. All right, now this one says find the slope field that matches which equation over here. So we should be able to match a slope field to a differential equation. Now, if I look at this one, let's see, my rows are not the same. So that means it's not a Y, so it can't be that one. My columns are not all the same, so it can't be an X. So that leaves it to be these two. So I'm just thinking about the properties. If you're in X, your columns have to be all the same. If you're in Y's, your rows have to all be the same. So I can eliminate those because this one doesn't have that. Then the next thing I would look for, I look where I have equals or the 0. I've got a 0 along this negative diagonal. All right, along the negative diagonal. So like -1, 1, -2, 2, negative a half. So along that diagonal, I have zeros. So if I take a positive and a negative number, if I add them or if I divide them, which one's going to give me 0? Well, of course, it's going to be this one. So if you take the point -1, 1, you add the coordinates, you're going to get 0. If you take 1, -1, add them, 2, -2, add them, you're going to get 0. So it's got to be C. So that's the differential equation that matches that grid. So we should be able to do that, match those slope fields. And you should be able to draw the solution curve. So this one here is actually a part A from a free response question from the AP exam. It says draw a solution curve that goes to the point 0, 1. So 0, 1's right here. So I would want to kind of follow, I think I'll just do the straight line. You can do a straight line. You can also curve it off and let it go that way. It's totally up to you. And then the other one says sketch the solution curve that passes through 0, -1, which is this point down here. And so I would kind of do follow my slope field. Got a little hump in there. Let's get that away. Just follow that like that. All right. So it can look like that. Or like I said, this one can veer off and come down like that. That would be just as correct. All right, you just have to follow the slope field, go from end to end. Don't go backwards. Make sure what you draw is a function. So make sure it passes the vertical line test. So that means you can't do something that passes back on itself. You can't draw straight down because that doesn't satisfy the vertical line test. So right here, if I were to go straight down, that would be wrong. I have to make sure I angle this. So my function has to be a function, has to pass the vertical line test. So, and don't go back underneath yourself because that would fail the vertical line test. So do those kind of things, go to the end of the grid. Here's what the rubric shows is actually the answer. But they counted it correct too, someone that went like this and followed along. As long as they followed the slope field, they were counted correct. All right, so that's a little review on slope fields. I think slope fields pretty easy. And what you learned at the same time with slope fields was separating and integrating to find the actual solution function in a particular solution. So that's what we did when we did all this last year. All right, now the next thing I want to talk about is Riemann sums, but I think I want to make 3 short little videos. So that little video is the one on slope fields.